All right, everyone. Now let's talk about one of the most exciting feature introduced in vSphere 8 Update 3, ESXi Live Patching. This feature is designed to dramatically improve operational efficiency, reduce downtime, and strengthen security in production environment. Let's understand the traditional patching process first, and then we'll go to the ESXi Live Patching new feature. In the past, whenever a security patch or update need to be applied to ESXi, administrators had to follow a lengthy process. First, all running virtual machine had to be migrated off the host using vMotion. Then the host had to be placed into maintenance mode. After that, patches were applied and the host had to be rebooted. And finally, validation we need to perform, right? This process was time consuming and disruptive, especially in large environments. Now, just imagine doing this across, dozens or hundreds of hosts. It's a tedious process, right? That's why VMware introduced this ESXi Live Patching feature in vSphere 8 Update 3. ESXi Live Patching allows administrators to apply security updates to ESXi host without evacuating the workloads and without rebooting the ESXi host. Yes, no vMotion is required and no restart required for the ESXi. The goal is very faster and the upgrades will perform with zero downtime. Sorry, not upgrades, update. This is achieved using two key mechanisms which is introduced in ESXi Update 3. One is partial maintenance mode. Another one is fast suspend resume, which is also called FSR. To use vSphere Live Patch in the production environment, we need to meet some prerequisites. The first one is vCenter version must be 8.0 update 3 or later. ESXi host version must be 8.0 update 3 or later. Then live patch settings. To enforce live patch, we need to enable the live patch settings in the global vSphere lifecycle manager remediation settings or the cluster remediation settings. DRS must be enabled on the vSphere cluster and it should be in fully automated mode. vGPU enabled VMs. So we need to enable pass-through VM DRS automation, that needs to be enabled. Then next is patch eligibility. The current build of the vSphere cluster must be eligible for a live patch, that needs to be verified. So these are the requirements for vSphere live patch. Now let's try to proceed with the next step, how this patch works. All right, everyone. Now let's try to understand how live patching actually works internally in vSphere 8 Update 3. This diagram shows the complete workflow from start to finish. Let's go step by step. Step 1 is partial maintenance mode. First, the ESXi host enters something called partial maintenance mode. Now, this is different from normal maintenance mode, right? In normal maintenance mode, all VMs must be migrated to other ESXi host. But in partial maintenance mode, existing virtual machines continue to run on the same host. However, certain operations are restricted. For example, we cannot deploy new VMs when we are using this partial maintenance mode. We cannot perform vMotion migration from other host to this partially maintained maintenance host. So the host becomes stable for patching, but still running some workloads on it. Think of it like putting a server into a controlled state, not fully offline, but with some restriction. Step 2 is load new patches. Next, vSphere Lifecycle Manager loads the required security patches. These patches are prepared and staged on the host. At this point, no reboot has been happened and workloads are still running normally. This is where live patching becomes more powerful because traditionally patching would require downtime, but here everything continues operating. There is no downtime required. Next, we need to understand about this fast suspend and resume feature, FSR. Each virtual machine briefly enters a suspended state for a very short time. This pause is extremely quick, usually in milliseconds. Like if you are watching a movie, we will be pressing the pause button from the remote, right, to stop it for some time. Similar to that, here the virtual machine is paused during this operation for some milliseconds. So during this moment, the hypervisor switches from the old version to the patched version. So from our perspective, application continue running without noticeable interruption. So instead of rebooting the host, VMware temporarily pauses VMs, patches the hypervisor and resumes them. This is the secret behind zero downtime patching. Then finally switch to patched hypervisor. After the FSR process completes, virtual machine resumes operation on the updated hypervisor. Now the ESXi host is fully patched, but workloads never had to leave the host. That is one of the main advantage of using live patching, right? So we successfully applied updates while VMs kept running. So to conclude, the hypervisor gets patched, virtual machines stay online, no reboot required, no workload migration required. This reduces maintenance window and operational complexity in the production support. Now we understand how live patching works and its advantages. Now let's talk about something very important, the limitations and the potential risk of using this live patching. Because in production environment, no feature is perfect, right? Even though live patching reduces downtime, administrators must understand where it may not work as expected. So first one is patch compatibility. First of all, we need to think that not all patches support live patching. Some updates require deep changes to the hypervisor, especially VM kernel updates. In those cases, a reboot is required. So live patching cannot replace traditional patching completely. Okay. So before applying a patch, administrators must verify whether the patch supports live patch compatibility or not. If you try to apply an unsupported patch, the system may fall back to the old method. In production, this means you must always plan maintenance window just like the traditional method. Limitation 2 is difficulties in testing and verification. The challenge here is testing. Normally, after patching, a system administrator reboot and verify that everything is functioning correctly. But with live patching, there is no reboot. So verifying whether the patch fully applied can be, more complex to verify, right? Also, some issues might appear later because the system never went through a full restart cycle. That's why, organizations should always test patches in staging environments before applying them to the production clusters. The final limitation is potential performance impact. This is very important because during the fast resume, suspend resume process, virtual machine briefly pause for some milliseconds or some seconds. Although the pause is very short, latency sensitive workloads might still notice that. Okay, like especially database servers, the IO is very frequent at high rate. Also, patching operations consumes the system resources. So during heavy patching activity, the host may experience slight performance degradation. So in most environments, this impact is minimal, but in high frequency trading systems or real-time applications, it matters, right? So what we need to take away from this limitation is live patching is powerful, but it must be used carefully in the production support. Always verify patch compatibility before you start using this live patching option. Best approach is test in non-production environment, okay, and monitor the performance after patching for 2 to 3 days. So think of live patching as a tool to reduce downtime, but not eliminate the complete traditional patching approach. I hope you understand both the advantages and limitations. So that will help administrators to decide when to use live patching and when to follow traditional methods. So this is very important from real-time perspective.